Welcome to SAM Networking Labs. Today we are going to work through a practical web security lab from Portswigger. This lab focuses on exploiting path mapping discrepancies for web cache deception. The goal is to obtain Carlos's API key by exploiting a vulnerability that arises when the origin server and the cache server interpret URL paths differently. This is a common vulnerability in web applications and an important topic for security professionals. Let me explain the attack at a high level before we dive into the steps. Path mapping discrepancy occurs when the origin server and the cache server interpret URL paths differently. The origin server uses RESTful mapping, which means it abstracts the URL path and ignores extra segments. The cache server uses traditional mapping, which means it interprets the full path literally. The vulnerability is that the cache sees a static extension such as .js and caches the response, but the origin server ignores the extension and returns dynamic content such as an API key. This discrepancy allows an attacker to poison the cache with a victim's sensitive data and then retrieve it. Let us begin with the prerequisites. You need the lab credentials, which are username Wiener and password Peter. The target is the victim user Carlos. You will use Burp Suite, including the proxy, repeater, and intruder tools, as well as Burp's built-in browser. Step 1 is to log in and identify the target endpoint. Open Burp's built-in browser and navigate to the lab URL. Log in with the credentials Wiener and Peter. Confirm that the response contains your API key. In Burp Proxy, locate the GET request to /my-account. Right-click on this request and send it to Repeater. Step 2 is to test the path mapping discrepancy. In Repeater, modify the path to /my-account /abc and send the request. You should receive a 200 OK response containing your API key. This confirms that the origin server abstracts /my-account and ignores the /abc segment. Now modify the path to /my-account /abc.js and send the request. You should see the response headers containing x-cache:"miss" and cache-control:"max-age equals 30. The miss indicates that the response was not served from cache because this is the first time this URL has been requested. The max-age equals 30 means that if the response is cached, it will be stored for 30 seconds. Now resend the exact same request within 30 seconds. You should now see x-cache: hit in the response headers. This confirms that the cache has stored the response. The cache interpreted /my-account /abc.js as a .js file and cached it. Step 3 is to craft the exploit payload. In Burp's browser, click Go to Exploit Server. In the body section, insert the following HTML script. Script tag, document.location = https://yourlabid.web-security-academy.net/my-account /wcd.js, closing script tag. The script executes a redirect automatically when the victim views the page. The document.location redirects the victim to the malicious URL. The /my-account /wcd.js is the malicious URL that triggers the cache deception. Change the WCD segment to a unique value each time you run the exploit to prevent the victim from receiving your cached response. Click Deliver Exploit to Victim. What happens now is that Carlos visits your exploit server page. His browser redirects to /my-account /wcd.js, the origin server returns Carlos's account page which contains his API key, and the cache stores this response as if it were a .js file. Step 4 is to retrieve Carlos's API key. In a new browser tab or in Burp Repeater, visit the following URL, https://yourlabid.web-security-academy.net/my-account /wcd.js. The response should contain Carlos's API key. Look for the text API key : followed by the key in the response body. Copy the API key. Then click Submit Solution and paste the API key. Let me summarize the attack flow. You log in as Wiener. You test /my-account/abc.js and confirm the cache stores the response. You craft an exploit that redirects Carlos to /my-account/wcd.js. You deliver the exploit to Carlos. Carlos's browser requests /my-account/wcd.js. The origin server returns Carlos's account containing his API key. The cache stores the response as /my-account/wcd.js. You request /my-account/wcd.js. The cache returns Carlos's API key to you. And you submit the solution. The key headers to watch are x-cache with a value of miss indicating the response was not served from cache, x-cache with a value of hit indicating the response was served from cache, and cache-control with max-age equals 30 indicating the cache stores the response for 30 seconds. Common mistakes include getting x-cache:miss on the exploit request. The solution is to wait for the victim to visit first and then request it. Another mistake is the victim receiving your cached response. The solution is to change the arbitrary segment such as from wcd.js to wcd2.js. If the redirect is not working, ensure the script tags are correctly formatted. If the API key is not visible, check the response in repeater rather than the rendered browser page. This attack works because of the discrepancy between how the cache and the origin server interpret the URL. The browser sends a GET request to /my-account/wcd.js. The cache sees /my-account/wcd.js and matches the .js rule, so it caches the response. The origin server abstracts the path to /my-account and returns Carlos's account. The cache stores Carlos's response, and when you request the same URL, the cache returns Carlos's API key to you. The key takeaway is to always verify that sensitive endpoints are protected with cache-control::no-store, private headers to prevent this attack. Thank you for joining me today at SAM Networking Labs. Good luck with your studies.